This short video will take you through the main controls of the Directional Drilling Simulator DDSIM. When you first run the software up, you'll see this menu on the screen, and you'll be given the option of a new exercise or previous status. A new exercise means that you can choose from one of these and carry on from scratch. A previous status means that you want to carry on from where you left off the last time you shut the Directional Drilling Simulator down. Okay, I'm going to start with a new exercise, and we're going to go for the S-well, relief well exercise. You'll be given a choice of a number of bottom hole assemblies. I'm going to run with number 10 here, which is a slick motor and bent sub, and it will produce about 3 to 3.5 degrees per 100 feet of dogleg severity. Okay, having selected that, we then see on the screen all the instrumentation that we need to go and drill the well. I'll maybe make that just a little bit bigger on the screen here. Top left is the Rotary Rpm. Then we have a weight on bit indicator here. The weight on bit is on the outside of this one, with the weight on hook in the inside. Sometimes that's the other way around. Then we have the Rotary Lock on the top drive here. We have the Drawworks clutch, which can be engaged or disengaged. We have a brake handle over here, and the more we release the brake, the less friction there is on the Drawworks drum, and the drill pipe and the assembly will go down the hole. If we engage the clutch and raise the brake, then power will be applied to the Drawworks and the drill pipe will come out of the hole. Over here we have the drill pipe pressure from the drilling fluid in PSI, and then the strokes per minute gauges on 2 tandem pumps down here. They'll always just work together. Here we have the survey panel, and at the moment we're sitting at bit depth 0, but we have 615 feet already drilled out of open hole beneath us. Here's a viewing window, and if I press the letter V for the viewer, I can also see a directional driller's plot. This will show you your well plan in profile plot view and also in plan view. This well kicks off on a direction of 230. That will be important later. And we can zoom in on this. So I can use the slider bars here to zoom in on any part of the well profile. And what you'll then see is in blue, you'll see where you've actually drilled compared to where the well plan wants you to drill, and you can see whether you're above, below, left or right of the line and have the right angles or whatever. Okay, we can clear the viewer off there, and let's go through the controls. They're all key codes, and there's a little help screen here, which if you open up the help screen, it will show you a brief summary of all the key codes just in case you forget one. Okay, Rotary RPM. If I want to increase the rotary, I use the right hand arrow key. So if I tap the right hand arrow key a few times, I can increase the RPM. Left hand arrow key would slow it down. And then to handle the brake here, if I use the up arrow key, I can release the brake, and the down arrow key applies the brake. So I can slow things down or go all the way to the bottom, and the Drawworks brake will lock up. Okay, I'm going to run all the way into the hole. You'll notice that we don't take time to make up connections in the simulator. It's treated like one long continuous drill pipe. However, I'm tripping 600 feet here, so you can accelerate time by just pressing the letter A for alpha. You press it once, it will double time. If you press it twice, it will quadruple time. Press it 3 times, and it's now 8 times normal time. Press it again and you'll probably go to the centre of the earth. Anything you do with the brake will cancel that, and so I'm applying the brake just before we go to bottom, and we're now at 612 feet. Okay, on the right we have the Rotary Lock. You can consider it to be a rotary table or a top drive. It doesn't really matter, it's all going to behave in the same way. And if I turn the rotary off, I can press R for rotary table and it will lock. And now the right and left arrow keys are no longer functioning. If I unlock, now it's free to rotate again. For the drawworks clutch, if I press D for the drawworks, then it engages the clutch, and now when I raise the brake with the up arrow key, power is applied to the drawworks and the drill string will lift out of the hole. Now I want to go on bottom shortly, so I'm going to release the clutch there, raise the brake and take it back down to just off bottom. Over on the left here we have the drill pipe PSI and the 2 pumps. To increase circulation, I use the plus key. Now on a laptop sometimes you need shift to get the plus key above the equal sign. But I'm going to take the pumps up to 100 strokes per minute. If you need to put the pumps down, it's the minus key. Okay, because I'm using a mud motor, you can imagine now that with the pumps running, the drill bit is now turning. So if I was to go on bottom, I would actually make hole. However, I'm going to have to lock the rotary table on a given tool face for me to be able to kick off in the direction I want to go. So first of all, we need to kick in the surveys, and it's S for survey, and once you've kicked it in, it will stay live on the screen. Okay, at the moment we have a hole direction of 0, an inclination of 0, and an azimuth tool face telling us the direction that the bend is pointing in is 87 degrees. Now that's already corrected to grid, so we don't need to do any corrections on that. I'm going to turn the rotary table though to go round to my desired heading of 230, just to show you a little problem that we're going to have when we try and kick off. It's a little bit of a skill, just tapping right and left to get exactly the number that we want. I'll press R to lock the rotary, and now if I raise the brake and go on bottom, you'll see the impact of the torque when it makes contact with the bottom of the well. And the first thing you'll notice when we come on bottom is the weight goes on the bit. We've got 10,000 pounds of weight on the bit. You'll see the pressure going up in the standpipe, just because we're now working the motor harder and the bit nozzles are working harder, so we see that pressure rise. But notice also that the tool face has gone something like 10 degrees to the left of our original 230. Well, this is because the drill pipe is locked in orientation away up at the top drive, but the torque being applied at the mud motor is right down at the bottom of the well. And so the whole drill string is twisting to the left to help generate that torque in the mud motor. So with that reactive torque being around 10 degrees of twist in the drill pipe, I would be better to set the azimuth tool face to maybe 240 off bottom. So I'm going to put the clutch in, D for the drawworks clutch, just come off bottom a little, release the clutch again, D, and I'm going to unlock the rotary table and just buy myself another 10 degrees to allow for the reactive torque. Relock and put the weight back on. And now when I make contact, the reactive torque has turned me back to the direction I really want to kick off in. Now notice that there's nothing yet in the hold direction or in the inclination, but that's because in this assembly the sensor is 44 feet back from the bit face, and so it may be a while but until we see survey data coming up from the sensor. So at the moment it's still in the vertical part of the hole. But if I accelerate this, just so you can see that coming in, you'll see the hold direction, a little bit unstable at the moment, but then it stabilizes out, and you can see that initially I kicked off on 220, then corrected for it, and you can see the hold direction has recovered there as we build up inclination. Well, I'm going to apply the brake for no other reason than to slow down that acceleration to demonstrate that, and now I'm drilling roughly in the direction that I want to. If we were to look in the viewer at this point, all we would see in the viewer is that the top part of the well has gone blue, and that's because that's my as drilled so far. I'm going to zoom in a bit closer than that and go right to the top of the well and close in on the surface, and you'll see it's now blue all the way down here. If I slide down there, you'll see that we've actually only just started to kick the well off here, so the blue is kind of overwriting the black in that picture. We haven't got enough step out to really see it yet in the plan view. Okay, I'm continuing to build here, and you notice an interesting effect, that the tool face appears to be dropping even though I haven't made any adjustments to the orientation. Well, this is partly because the drill pipe is being extended downhole, and so more drill pipe is more steel to twist, and so for the same reactive torque we get a larger twist angle. So this is going to get worse and worse the deeper we drill. By the time we get down towards the target, that could easily be 100 degrees of twist with only 10,000 pounds of weight on the bit. Notice too that if I was to raise the brake at the moment and put more weight on the bit, then there would be more reactive torque as well, and so my 229 has dropped to 225. If I put even more weight on the bit, it's down to 221. Now we're almost at the limit of what this mud motor can take in terms of pressure. If the standpipe pressure exceeds 3000, I'm likely to stall the motor. I'll show you that. If I go above 3000, the motor is now really struggling and we're pumping fluid straight through the motor. So I'm going to take the pressure off that, and I'll come back down to keep my tool face roughly on the direction I really wanted to kick off. Now another interesting thing is going to happen once we reach 5 degrees of inclination. At the moment, the tool face that we're displaying is an azimuth tool face, and so it's really just telling us the direction that the bend is pointing in relative to grid north. And the letter A on the left hand side there is to tell us that that's an azimuth tool face. So the number in that box will go anywhere between 0 and 360. However, once the inclination goes above 5 degrees, the sensors in the MWD detect that we're now at an angle where we can use the high side tool face, and it will automatically switch over from azimuth to gravity tool phase or high side tool phase. And you'll see in the bottom display the number will suddenly change. Here it comes. It's now telling me we're sitting 0.2 of a degree to the left of high side. My hold direction at the moment is 228, and I would really like to be on 230. So I'm actually going to stop at the moment, unlock the rotary, just buy myself maybe another 10 degrees, relock with the letter R, and put the weight back on the bit. Now this has given me a slight right hand tool face, and as I continue to build, the right hand tool face will eventually improve my hold direction. You can see at the moment that the hold direction according to the sensor is still turning to the left. But again, that's because the sensor is 44 feet back from the bit face. And so only when we get 44 feet further down are we going to see the benefit of that tool face change. Well, let's just accelerate the time again to see that. And there it's going the other way, and now my hold direction is improving and heading back towards the 230 that I was looking for. Now I'm going to apply the brake to just stop the acceleration on time, no other reason than that. And I'm going to continue to drill with that slight right hand tool face for now. Our inclination now is up at almost 9 degrees, and so if I was to go and take a look at the picture now, I might be able to see a little bit more of the weld path when I zoom in at the top level. So we'll zoom in right up hard to the edge and come up to the kickoff point, and there you can see in blue I'm drilling a little bit faster than the curve. In this exercise, the curve is designed at 2.5 degrees per 100. I said earlier that the assembly will do anything between 3 and 3.5 degrees per 100, and so I'm getting a little bit ahead of the line. Well, that's fine. What I'll do is I'll rotate a little bit now and allow the weld plan to catch up with me a little before continuing. In order to rotate, I'm going to put the brake on, the drawworks clutch in, letter D, come off bottom a little, release the clutch, R to unlock the rotary, and I'm going to put maybe just 30 RPM or something on there. Remember that most of the revs at the bit are coming from the mud motors, so I don't need high revs from the top drive to be able to drill ahead in a straight line. Okay, so now I'm ready to go on bottom. Putting a slightly higher weight on the bit this time, but I'm still staying within the limits of the motor. And now my penetration rate has increased quite dramatically. So if I drill ahead maybe for another 100 feet, and then I'll go back to sliding mode to continue. So you get the idea with the main controls. There's a couple of other tricks though in there that you should know about for some of the exercises that we'll be doing later on. One of them is if we want to record a fully calculated survey, we can press the letter X. And X will give us the measured depth, the inclination, the direction, the TVD, the vertical section, the northing and the easting. So if we're putting this onto paper, we can use that northing, easting and TVD and vertical section and plot them on our two plots. If we want to pulse up a long survey instead of a short survey, if we're running a multi-station analysis exercise or a short collar exercise, or even just a basic quality control exercise on the MWD, then you can press the letter G, and G will give you what the sensors are picking up as raw data. So we've got GX, GY, GZ, BX, BY and BZ. And from these we can then process them using the multi-station analysis software. Another thing that you should be aware of is you will get occasional warnings coming from the software. So for example, if I wanted to change the bottom hole assembly, then it's simply the letter B to change the assembly, but clearly if I press it now, it's going to give me a warning that I can't change the assembly, I'm still downhole. So watch out for the occasional warning like that. It's very difficult to do any serious damage. The one thing I would warn you about is too much use of the accelerator key. It's fine when you're tripping, but don't use it when you're drilling. So there we have it, and good luck with the exercises.